Welcome to Fargo FX. We've got an interesting show today. A couple of weeks ago I did a project where I made a kind of cleaver knife, and I made that from a scrap of steel that I'd picked up from a local welding shop here. And I assumed it was a low carbon steel. That's generally what welders work with, and that really isn't enough carbon to be able to quench the steel and expect any kind of significant or at least consistent hardening. So with that project, I just sharpened up the cleaver, I left it unhardened, and I split some wood with it, chopped some wood, and showed that you really can make a somewhat functional knife, depending on the purposes you're going to use it for. You really can make a functional knife with mild steel. Of course, a lot is going to depend on the edge geometry. You're not going to be able to get a really fine, thin edge that's going to do really great cutting or slicing type tasks. And if you do, it's going to go dull really, really fast because, of course, you have not hardened that steel. But I noticed something interesting while I was editing that video. I noticed that while I was grinding the steel, the sparks that came off were not really showing the usual behavior that you see from sparks when you have a very low carbon steel. Now, I'm not an expert on this, but I know that with low carbon, you usually see sparks that are long and thin, and they don't really pop. But with the high carbon steels, you'll get these really energetic bursts as the sparks come flying off the steel. In fact, it almost has a fireworks kind of look to it. And I noticed in that video, I was seeing a lot of those kind of sparks. So that got me thinking, and I started wondering about the composition of that steel. Obviously, it's a total mystery to me. It was just a scrap that I picked up someplace. And it could be that in some types of industrial steel, they use other alloys that could cause sparks like that. But as a knife maker, I'm always looking for inexpensive steels, especially to practice with. And since I have quite a bit of this steel left over, I thought I would test a few pieces and see if this stuff can really be hardened and also properly tempered. Now, a few months ago, I did a similar test to this with some rebar. I will link to that video if you want to check it out. But the idea here is to get three pieces that are all about the same size. I'll leave one of those pieces in a softened state, quench the other two, and one of those I will also temper. So I can compare the three and see if there's any difference in toughness and hardness between the steel in those three different states. So I'm starting out with a piece that's kind of it was a side piece of the original scrap that I was using. It has kind of an irregular but triangular cross section to it, and it's definitely a little on the thick side. So what I'm going to do is cut off a nice long piece from here, and then I will forge it a little bit flatter and then cut it into three equal lengths. Now, I've said this before, but I'll say it again. Anytime you're grinding with steel, you definitely want to have some protective gear. Obviously, you're going to want to protect your eyes. But it's also very important to have some type of respirator, some kind of a mask that will keep you from inhaling those tiny particles. For this job, I knew I wasn't going to be grinding very long, maybe just a couple of minutes. So I decided to just put on one of those little disposable masks. But when I got done and looked at the mask, I was actually kind of shocked to see how much buildup there was inside of there. I don't know how clearly that comes across in the video, but that mask is supposed to be just a nice clean white, and you can see a lot of little dark patches and areas in there. That's all from the, the dust and the remains of the sparks, burned up steel and stuff that's just floating around and gets inhaled into this mask. So looking at this, I would say even for a small task like this, it's worth putting on a full respirator. And you can find them just about anywhere. They're really not that expensive. You can find them at hardware stores, home improvement stores. I do have an affiliate link now with Amazon, so if I can figure out how it works, I'll put a link to that in the description below. And if you want to use that link, you can check out the mask that I ordered through Amazon. So once I had the piece cut out that I wanted, I took the grinder and I just kind of went over the edges to get rid of any snags or metal slivers. Took a good look at it, made sure there was no cracks or any kind of imperfections. And then I took the piece to the forge, heated it up, and you'll see me here flattening it out. I'm not really doing a lot of forging here. I just needed the piece to be a little bit thinner for the tests that I'm going to do here in a minute. The other nice thing about doing some forging on this is that it gives me an opportunity to heat the metal back up beyond that critical temperature and at least mostly normalize the metal. The idea there is that the manufacturer of this material maybe did some type of heat treat of their own. Sometimes they'll do a case hardening or some other type of process to give it certain qualities or characteristics that they're looking for. And I really don't know anything about those industrial processes, but I do know that if I get the metal up to a good forging temperature and then let it cool very slowly, I should have a very soft piece of metal. Once I had it forged to the size and shape that I wanted, I just marked out three equal lengths and I cut it into three pieces. And then all three will go back into the forge to get heated up again beyond that critical temperature. Now, I don't have a thermometer for checking the actual heat of the steel, So when it comes to heat treating, sometimes I'll use the magnet test. If you get steel up to proper quenching temperature, it will be non-magnetic. But unfortunately, I couldn't find my magnet today, so I just went by looks. And what I looked for here was a bright cherry red type of color. And then just to be sure, I heated them up a little bit beyond that. So this first piece, I'm just going to leave on the edge of the forge here where it's well within that hot area around the forge. That'll be a good place for it to cool very slowly, and that should leave the steel quite soft. With that out of the way, I quenched the other two pieces in cold water. I did change the water between the quenchings to make sure that we had good, consistent temperature. The water has been sitting out here in the shop. I think it's probably right around 40 degrees. And if there is enough carbon in this steel to harden, this should definitely do it. Now for the piece that I'm going to temper, I'm actually going to grind off just that surface oxidation. So I have some nice clean steel that I can look at to watch the oxidation colors. Now if you're not familiar with tempering steel, the whole purpose behind it is to reintroduce a little bit of softness to the metal so that you have more resilience. If there is enough carbon in the steel to really harden with that quench, the result will be very hard steel, but it will also be somewhat brittle. So in order to keep that steel from breaking or chipping or shattering, we'll temper the steel, usually somewhere between 350 and 450 degrees for knife makers, depending on the steel and depending on exactly what you're going for. And in a way, what you're doing is you're kind of reintroducing a little bit of softness to the steel, just enough to give it some resilience. Now, there are expensive heat treating ovens that are made specifically for this purpose, but if you don't have access to equipment like that, it's really not a big deal. What I generally use is just a toaster oven that I got at Walmart. And then, as I mentioned, it's nice to have a nice clean surface on the workpiece, because as the steel heats up, there'll be oxidation that forms on that surface. And you can judge by the color whether the piece is properly tempered. So in this case, I set the oven at 450 for an hour. The color we're looking for here is what they sometimes call a straw color. This looks a little bit darker than that, almost into like a dark straw or a brown color. But that definitely lets us know that the steel got up to a temperature that it should be properly tempered. But again, that's assuming that it was hardened in the first place, and that's what we're about to find out. To begin with, we'll be testing the piece that was softened and was not quenched. I'm locking this piece in the vise, and I will be hitting it with a 2.5 pound hammer. And you'll see that it starts to bend really from the first swing. After a few more hammer blows, this is bent to a 90-degree angle. You can see, looking at it even very closely, there's no sign of any kind of cracking or any type of stress to the metal. And really, that's exactly what you'd expect from a piece of soft steel. For the second test, I'm using the piece that was quenched but was not tempered. And after a few blows with the hammer, you can see that it really hasn't bent at all. And if I had a more stable platform, I could probably use a heavier hammer and we might actually be able to break this piece. But it's pretty obvious that this piece is much harder than the first piece we tested. And honestly, I find that kind of surprising. If this was truly a mild steel, a very low carbon steel, we really wouldn't expect to see much hardening at all. So finally now we'll finish up with the piece that's been tempered. And I would say for this test, the performance of the metal is actually quite similar between the piece that was quenched and not tempered and this piece that was tempered. Both are clearly much harder than the unquenched piece. I think we did get just a little bit of a bend out of this tempered piece. And I expect we'd probably get a little bit more out of it if I had a more stable base to work with. But really the results here are pretty obvious. Whatever type of steel this is, it definitely took a hardening when we quenched it. So actually that probably suggests that we have a higher carbon content than what you would expect from an ordinary structural type of steel. So for me, as a beginning knife maker, somebody who's looking for steels to practice on and always looking for inexpensive options, this is actually a really intriguing result. Because it was leftover scraps at a welding shop, it really didn't cost me much at all. That's about all I have time for right now, but I will be making a knife with this steel and putting it through some different tests just to see how it holds up. So check back tomorrow, and if you're watching this in the future, you can just, I'll have a link here at the end and you can just click that link to the next video. And with that, I guess I'll say, whoever you are, whatever you're doing, have a wonderful day, and I'll see you in the next video.